So this talk's really about what's the business value of DevOps and why should you care? Why should you add this to your process? And really, it's a bit more conceptual than technical. So I have a bit of experience today. Again, I work as a developer evangelist at a company called App Dynamics, which is focused on application performance. Before that, I did a lot of consulting and training at a company called Sensu the creators of the Symphony framework and Symphony components. And then I brought Symphony to Yahoo to rebuild Yahoo Answers and Delicious a few years ago. So what is DevOps? By show of hands, who uses DevOps philosophy in their company? So I hear a lot of different definitions for what DevOps is. I think it's developers working together with operations to get things done faster and automated in a repeatable way. It's really a philosophy. It's not a set of tools. It's not just an ideology. It's really about the whole end-to-end process, but generally this is what the flow looks like. So you plan, you build, you code, test, release, deploy, operate, and monitor. It's just an endless cycle. And if you're doing it right, it flows from beginning to end, and it can just be repeated again and again. So how many of you have had a problem in production, and you go to the ops team, they say it's your fault, and you say, okay, no, it's the ops team's fault. I've had this situation happen again and again. Before I had all these developer roles, I was in network operations, and then before that, I did web hosting tech support like a long time ago. So I've dealt with every sort of operational issue you can imagine. But once I switched to the engineering side, the developer side, I really started to understand why ops just tends to blame developers. And I could relate to the developers blaming an ops team, because it's okay, this firewall is misconfigured, this thing's broken, etc. This service is down. So how do you get past that? The goal isn't to just be able to throw it over the wall and say, okay, this is your fault. It's really to be able to say, okay, what exactly went wrong? And it's about working with operations together so that they understand the code and that you understand the infrastructure, and that you guys can collaborate to solve problems faster. So this is traditionally how it goes. Ops says everything is fine from our end, and you actually have to go back and figure out what went wrong. So in network operations, usual day looked like this. Somebody would open a ticket. I'd have to make a ton of phone calls to figure out what's actually gone wrong and who's affected. Somebody comes into my office, bothers me for a status update, and says, okay, now you need to make this a higher priority, so it gets reprioritized. We argue about how important this really is. It gets reprioritized again and again, depending on what's going on that day. And then I try to close the ticket as not reproducible. Because unless something's just outright down, and it's just one user complaining, it's really hard to figure out what's going on when you don't have real visibility. And then hopefully go and enjoy yourself in the evening time, whatever that may be. So what do I care about? That I can wake up, that I can survive the day, and I can just rinse and repeat. But what does everyone else care about? P1s and SLAs. So P1s, priority one bugs, things that affect a lot of users, and our service level agreements. What do we promise to our customers that we'll provide? Because that you have to deliver on. The only thing that my boss cares about, the only thing the business cared about was money. It's sad but true. Like, downtime means we have to refund all of these customers because we didn't meet our SLA. That's your fault because you tripped over that power cord and unplugged this rack of servers. P1s equals money. So how do you actually justify this? When you have P1 incidents, how do you quantify the cost of one day's incidents? It's easy when you're an e-commerce shop and you say, okay, nobody could check out for 5 minutes. Here are all the orders that we were going to check out. Here's the value of that. But when everything's going right, nobody complains. Nobody says anything. Nobody gives you, nobody applauds your efforts because things are running smooth. But everyone's in your face as soon as something's wrong because they want an answer. They need to communicate to customers, and they expect you to come through with that answer. So even though the business can't always prove it, when you have severe bugs, it generally means cash for the business. Please forgive the slides. How the business really viewed me, general pain, because I was the person that they went to whenever they had problems. I was always a pain for the people below me for support because they would have to get escalated to me. So they didn't like me either, because by the time it got to me, their day's already been ruined. And then our other ops and our partners view me as a general pain because I'm breaking their services. They have businesses that rely on us. But most of the time, most of the bugs that I got were false alarms, right? The site is down, our search is slower, there are 404 errors, but usually it's a temporary problem and it went away and you can never reproduce it. So you go back to the drawing board, the bug will get closed until somebody else complains, and then the issue comes back. So 4 a.m. Friday, we have an alert, load on one of the servers, staging server is critical. How does that actually work? So how do you quantify the value of wasted time? Wasted time is the time that ops or engineers spend trying to find issues that don't really exist because a temporary network flip, somebody deployed some bad code, things that you don't have control over, but you're the first line of defense, so people come to you with those issues. So how do you actually quantify how much time was spent and the actual value of that to the business? So it's pretty easy if you just average this out over how much time is spent per week and the actual cost per year. And what you realize is that this really adds up to real money. And when you can quantify this to an executive team, you can show your value. Both you can show success for when things are going right and all the hard work you put into making sure the infrastructure is set up and monitored correctly, but also when things go wrong, you can say, here's the actual business impact. So being able to quantify this is very important, I think. As I've grown in my career, that's something I've learned because when I was a first line support engineer, it didn't matter to me. All I knew is I had this bug that I needed to resolve and I needed to figure out what was actually going on. As I grew up, as I sort of moved up the chain, it started to become, okay, so how much is this going to cost us? How do I explain this to our customers? How do I manage our partners? How do I manage expectations? And how do we keep our credibility? And for that, you need real calculations. And that's sort of about what this talk's about. So being able to prove how much revenue did the business lose and basically how much you've saved the business in money when you're doing things correctly. So generally, if I ask any of you, can you tell me how much a P1 incident cost you last year or how many P1 incidents you have? You can probably pull up a bug tracker of some kind and filter by P1s and tell me here's all the issues. But can you tell me how much they actually cost? By show of hands, anybody have an even rough idea? Right, I found that a lot of people don't. It's really a black box, right? So why not? Because this is the process. There's no instrumentation, there's no monitoring, there's no additional tools, right? So you just go through this basic process of going through bugs, talking and communicating with your team, reprioritizing the bugs, closing them out, and then moving on with your day. But at no point are you instrumenting that and monitoring it for incremental improvements. So what did I wish I had that I have nowadays? So with infrastructure as a service like Amazon's Amazon Web Services, the better tooling that we have, so you have Chef, Puppet, Ansible, Salt. Collaboration tools have evolved a lot, like Jira is amazing nowadays. GitHub social coding is amazing. It's really easy to track different issues. Plus they all integrate with each other, so it's very easy to have complementary tools in an environment. And then business metrics. So how can I actually tie this to our application and convey it to the executive team? So things I wish I had done. I wish I knew where I started. So this is a big one that I don't think many people really realize. You got to understand where you're starting from to understand the change or the delta, right? So to be able to measure and communicate progress, you need to understand where you're starting from, instrument along the way, and track it over time. And then you need to be able to correlate that to the actual business impact. And this is something I've learned more importantly over the years is promote success and not problems, right? Everyone will come to you when you have a problem, but you need to go to them and say, okay, well, we actually, this year we had 99.99% uptime because here are the changes we made. We added Chef, so all of our servers set up identically. We moved over to using Nagios or some monitoring tool, and now we can always understand exactly the state of our services. It's not just about whether it's up or down, but is it performing correctly? And then you're able to prove your value and say, okay, well, I actually saved the company $100,000 this year, so maybe my $5,000 raise isn't a big deal. And these are things that I've done now. So present day, this is generally what most web applications look like. You have the open internet, firewall in between, some load balancers, some web servers behind a load balancer talking to a database. For a long time, this was a pretty standard setup, but if you're looking at real applications, they're a lot more evolved, they're a lot more complex. So this is a screenshot of the tool that we use called App Dynamics, but this is a real customer. This is a customer support tool that talks with a ton of different third-party services. So each one of these dots is a JVM or a .NET CLR or a PHP node. And for one request, they talk to all these services. So all of these can be points of failures. How do you monitor your problems? I can't tell you how much time I've wasted for somebody else's failure. Oh, PayPal's API is down, but our website's failing. I can't do anything about that, but I need to know that it's PayPal's fault and not mine in order to communicate that. I can spend half a day trying to figure out, like, is it a network problem? Is it a firewall thing? Who changed some code? And it's worse when you have a large team and people are constantly changing things. Like, oh, you just pushed this release out that morning. At the same time, they just happen to have a network blip at PayPal side. You think it's the release, you spend all day chasing that. How do you actually understand different points of failure? And how do you automate monitoring all of that? So if you've used Expedia or Travelocity, I believe this is an Expedia screenshot, if I'm correct. Yes, it is. Anytime you search for some travel, basically an itinerary, this is actually what happens in the background. It talks to all these different services, and any one of those fail, and now the travel search doesn't complete. How do you explain that to the end user? Or it gets super slow, right? So with a big shift to the cloud, being able to understand resource utilization is much more important, because resource utilization, the benefit of the cloud is that it cost scale linearly with demand. So the more machines I need, the more expensive they are. But the nice thing is you can turn machines on and off really easily, so you can scale up and down. But you have to know how to be able to do that at the right times in order to maximize, one, response time, and how much money you're spending in the cloud. So being able to chart it and plot it over time, essentially how much money are you spending per server and how many servers do you actually need? So being able to correlate the two. And what you can see is a minor improvement means real numbers, right? It's a massive impact on the business. So if you can shut off 20% of your servers because you actually don't need them and they're just overkill most of the time, you've just saved a lot of money per year. So this is actually a real customer of ours, and they basically save this amount of money by just figuring this stuff out. But how do you do that? What are the tools that you can use? So why does DevOps matter? How many of you are in the cloud today are based in like AWS or Rackspace? Nobody?
There's some metal on.
Usually there's more people. I figure like it's like 1 out of 5. But yeah, no, I think that a lot of people are based in the cloud and they have their own challenges, right? One, in correlating costs. Like all this doesn't matter if you've already bought the servers up front, you've co-located them, you've built all of this. Most of that stuff doesn't matter. But I think a lot of people who are based in the cloud, you're basically choosing which problem set you want to focus on. When you deploy your own hardware, so I used to be a NOC engineer and I would go and build out racks. And that's fine, except for it's super expensive and you need to control everything from the power supply to the colo. When you're managing a data center, you control everything from the power supply, bandwidth, you need to be able to fail over in case of catastrophic events. All of those are your problems. That's basically the on-premise option, right? On top of that, you have to manage your application, you have to manage your data, any virtualization, any storage and networking, right? But if you move to something like infrastructure as a service, you choose a smaller set of problems to focus on. The only thing that matters is you control everything from the OS up. But if a server fails underneath, it's not your problem. You're not going to be an engineer who goes into the data center to fix it. And then there's a lot of platforms as a service. I think this is probably the easiest or the lightest weight. Just you're managing your application, your data. So if I can just deploy my app, as long as my code is working correctly, the rest is not my problem. I can just push it to a new server. So you have to pick which problems do you want to spend your time solving. The cloud enables you to essentially be more granular with that, right? Before, your options were always, I can just go to a web hosting company and they control everything. And I have very little options outside of uploading my code. I can co-locate or I can get dedicated servers. And then it evolved into a lot of VPSs, virtualization took off, And it's sort of just evolved from there. Now you have massive cloud offerings where everything can be automated via an API. So you no longer, you want to provision a new server, cool, you click a button, it makes an API call, and you're done. So automation. Automation is all about time is money, and business people like money. So what can you automate? Everything is automatable nowadays. From deploying a server via an API call, to notifying the ops team through something like PagerDuty. There's a ton of great tools that are available today to solve these sort of problems. So how many of you use Chef or Puppet or Ansible or Salt? How many of you are aware of what these tools do?
I've used them in the past.
So really the goal here is to describe the packages that you want on the machine and the settings that you want on the machine. And you can essentially describe roles. They all do it slightly different. They all have pros and cons, but the general concept is I can tell you that I want Apache 2.2, PHP 5.4.8 or 5.5.6. I want to change these PHP settings. I want to set this time zone. I want to turn on display errors in development and display errors off in production. And you can manage not only your packages, but also your environments. And the best part about this is you can automate the setup. So when things fail, it's really easy to spin up a new instance, right? The more you can do that, the faster you can react. The faster you can react, the more you minimize the end user impact, right? So how many of you use deployment automation? So Jenkins, Capistrano, Fabric, all of these tools are really about, again, being repeatable, testable, and more importantly, automated, right? If I want to deploy my code, I used to FTP it way back in the day, and it was great. I could just like copy and paste. It was fantastic. Things were really simple back then. I didn't have to deploy 20 services. I didn't have 100 dependencies. It was a static HTML site. I maybe threw some PHP files in there, and I was done. Now deployments are, you have to orchestrate a lot of it. It depends on your environment, how many servers you want to deploy to, and then the deployments get a lot more complicated. I need to build my database schema. I might need to run some migrations. I might want to optimize some assets. I need to do all of that across 100 servers and then deploy. So how about log automation? I think log automation is key. So the problem here is that for logs, it's great to, so all these tools essentially allow you to put all of your logs from all of your servers into one place, into one data store that's searchable and indexable, right? The problem with logging, I find, is that developers have to have the foresight to understand what to log. And everyone understands after you've had like a serious incident, but nobody is like thinks about that edge case ahead of time. They're like, oh, that would have been great information to have that would have solved our problem today had I known about it. And then they always add it after. Oh, well, we'll know about it next time. And then you never have that problem again, so it doesn't matter. You should use some form of log automation, right? You shouldn't have to SSH into a machine and then copy the logs. It should be as easy as simply going into a UI and searching. So there's a ton of good tools. I'm a particular fan of Logstash and Kibana. But if you have money to spend, there's Splunk and Sumo Logic, which are offered as software as a service. Application monitoring. So for the longest time, I used Nagios. I actually still occasionally use Nagios. But Nagios is good if I want to check whether something's up or down. Maybe I want to collect some basic stats. But that doesn't tell me if things are working correctly. That just tells me that there's an Apache server that's responding. Maybe I'm checking for some basic content like the set my DustinWhittle.com, or does Dustin Whittle show up on DustinWhittle.com. But it's not telling me is the performance working? Like, did that take 10 seconds to make happen, or was that 100 milliseconds? And also when things go wrong, I don't get any detail, right? So there's a ton of great tools that allow you to do a couple of different things. One, measure availability and uptime, but more importantly, track stats and be able to graph them over time. So I'm a big fan of StatsD and Graphite, which allow you to track any custom metric you want, and then Graphite essentially allows you to build graphs from all of your metrics. So you can track availability, I can track response time. If I wanted to track business metrics, like how much revenue do I do per checkout, or what's the average number of items in a cart, You can track any custom metrics, so I think those are really valuable tools to add to your stack. And then if you're using something like Chef, Chef actually is a really powerful tool if you can combine it with Sensu. So with Chef, I can say, hey, I have a web role. A web role is an Apache instance with mod PHP, and I know that it should be running on this port, and if I go to this URL, I should get this address. Well, what Sensu will do is it'll take a look at all your different roles. It'll understand that this machine is supposed to be this role and apply health checks that allow you to check for specific quality data. So maybe I'm running a Postgres instance. Sensu will allow you to, one, is Postgres up and running? What's the current number of open connections? Am I anywhere near my max? And then you can set alerts based on that. And the same thing with like Apache. So if I describe something as a web role, how's Apache doing? Is it healthy? So it'll pull metrics from the Apache status page if you want. And then you can graph all that over time. But it's a really granular monitoring tool. And then you have things like Boundary and App Dynamics. So Boundary monitors the network flow. And then things like New Relic and App Dynamics allow you to instrument your application and check on the application's performance. So nobody ever files a ticket that says, hey, line 238 has a parse error, could you fix that? It's always, I can't check out, your site's slow as shit. Like, it's something really harsh, right? It's always like, this is impacting me and I can't make progress. So how do you fix that? How do you get insight into this? I think that's where like APM tools really come to play. So I work for App Dynamics, so obviously I'm a big fan of them. But the goal here is not necessarily to use this company, it's to use a type of solution to manage application performance. So there's a bunch of different options. At a minimum, in the open source world, you have XHProf, which allows you to do production monitoring. It's not as good and as well refined, but when you're having serious issues, they'll give you a call graph so you at least know where to look, right? And then you have tools like App Dynamics and New Relic that will really instrument your entire infrastructure and tell you when you're having performance problems exactly what went wrong. So how much time and how much money do these tools save? This is really the open question because most of these tools cost money. A lot of them are open source, but at the end of the day, you have to go and be able to justify to your team either we need to pay for this or we need to invest the time to customize this and actually integrate it so it works for us. That could be an hour of time, that could be several weeks, right? So I think this is really DevOps. I think this picture really captures it all. Dev and Ops working together. It's all about collaboration, right? Productivity reduces time. The more people collaborate, so one of the biggest time sinks outside of trying to debug third-party issues, like when PayPal's API is down, is the arguing and the bickering that goes back and forth between teams. When I was at Yahoo, the teams were 50 people spread out across 3 continents. It's really hard to collaborate closely when it's that geographically spread out, when the teams are that large. And it also means nobody has domain expertise. Like, there's not one person you can go to that understands everything. So you have to go between a bunch of teams and find out, okay, which piece do you own? How does this affect this problem, etc. Then I was at a small startup, and I designed everything from scratch, and I knew exactly what was going on. So that was me and 3 other people. That's a very easy problem to solve. But most companies are like between 20 and 50. So how do you solve that problem, right? How do you work together with the different developer teams and the operations teams? And I think part of this, it's not really about DevOps. It's about it's about corporate culture, right? How do you stop throwing it over the wall and blaming it on the other team? How do you just sit down and solve the problem? I think part of that, especially with engineers, is about ego. Look, it's not your code. Nobody's a special snowflake, right? Like every application is unique in its own way, but they all basically do the same thing. They accept some input from users, they put it somewhere, they take it back out, and they show it to you somehow. I think a lot of people get hung up on that, and that's what keeps them from actually finding like real problems. So it's all about collaboration. So productivity reduces time, time is money, business people like money. So what's the actual cost of trying to implement each one of these tools? So I think there's a couple pieces that are crucial. So infrastructure automation, if you're still in your own data center and managing your own hardware, I think you're probably, and a lot of times, it greatly depends on your specific problem, but I think that for the most part, you're wasting your time because you can either focus on managing your hardware and your infrastructure, or you can focus on solving your customers' problems, right? And then deployment automation, I think this goes without saying. I think people are long past FTPing and SCPing files over, but I still know a ton of people that do it. I still know a ton of teams, if I ask them, that's how they deploy every day. Oh, we SCP to staging, and if that works, then we just sort of SCP to all of our other servers and hope it doesn't go wrong. Right? So how can you add deployment automation and then log automation and monitoring are really about decreasing the time to resolution when you do have problems, right? Because that's what your executive team, that's what the business people care about. It's like, how fast can we get this sorted out? So that more information you have access to, the faster you can solve these problems. And then collaboration. Yeah, that's all about pride, but what's the actual benefit? So the DevOps value is what's the cost of all of these minus the actual benefit. But you need to be able to instrument that. So DevOps is automation and collaboration, which equals time, which equals money. So again, you can tell the business how much you save them. I think this is the key message I want for this talk has always been, it's everybody understands your value when things go wrong, but when everything's working fine, you don't get bothered, nobody gives you praise, and nobody cares about you, frankly, right? Like nobody cares when things are working fine, but everyone cares when things aren't. So how do you show success when things are still working fine? Because if you're doing your job properly and you're not having catastrophic failures, it's really hard to measure incremental change. So for the most part, this means instrumenting the number of tickets that you have and understanding and instrumenting the end user impact. So I covered a lot of this already, but treat infrastructure as code, right? It's another way to automate this problem. So instead of you having to build a new web server, a new database server, if you treat that as code, you've described it once, and now you can reproduce it again and again in the exact same way. A lot of the bugs I've encountered are dealing with, we set up this database server this way, and then we thought we followed the guide exactly, but we missed this configuration change, and now we have problems. Or, hey, we were trying to increase the number of read slaves on this database cluster. We thought we did everything right, but I was just following this wiki guide from 5 years ago, and it turns out it's out of date or no longer works. So again, the trick is make it automated. If you can, version it. So all of these tools are just, so if you use Chef or Puppet, and I don't want to go too much into the specifics, but it allows you to, again, just treat them as text files, and then you can put them in Git. So now you can be versioned. So version 1.0 has a certain configuration. When we deploy version 1.1, it needs to have this other configuration. Just like your application uses source control, your hardware should as well. Or your packages and your deployments should. And then it's testable. This is, I think, the most important piece, because people look at testing software code, but they rarely look at testing software configuration and the underlying infrastructure. If you treat all infrastructure as code, you really can make things testable. I can check, okay, once I've deployed once I've deployed a new server with the web role, can I check that Apache is listening on this port? Can I check that these virtual host settings are there? Can I check that this PHP version is correct? Can I check that these PHP extensions are available with this configuration, right? So now I can eliminate a lot of problems right there because I have a baseline. And then it's repeatable. If I want to add another machine, I simply
kick it over.
Yeah, kick it over. I'm done. I have no idea. We're gonna have to bring this back. Excuse me. No idea what that is. So again, the goal is to be repeatable, right? So I want to add another web server. Cool. New web role done, and it's exactly the same as the rest. Especially when it's when I want to add a new staging environment that I need to be identical to production. The only thing I wanted to really change is the severity of like the log levels. Well, I can manage that as just an environment change, and then I'm done. So tools, again, Chef and Puppet are great for that. Another one I'm a big fan of is Ansible. I would investigate that as well. But it doesn't really matter. You can bicker back and forth about which one you should use. They all have their own pros and cons. But just pick your flavor and get started. That's all it really matters. The other piece is being able to deploy in one command. How many of you today can click a button and deploy to staging? My point exactly. How do you deploy today?
How do we deploy you?
See? Deb does not understand how ops deploys.
I actually don't know. I never in charge of like based on production. I'm just deploy tests.
Okay.
Yeah, so I don't know real.
And this is very common.
Yeah.
Go ahead.
So we do a couple of different ways depending on the system. We're trying to move towards dev-driven deployment for everything. And we wrote a web app to do deployment and we don't like it, so now we're rewriting it. And we built one that sucked.
Yep.
So it's been kind of interesting. But before that, we got to like one command deployment because that's just when you start having more than like 5 machines. And
Well, that's
now
exactly
we're not like on a Yahoo scale, but we have like a couple hundred, and it's just.
Well, it doesn't matter. Even when it's 5, I'm like following the same wiki run book of like, oh, copy this command, run this, SAP, restart this service.
Right.
Right.
Everybody does.
And this is the thing. Whether it's 2 machine, I think it's really easy when it's a developer working in their development environment. But as soon as you want to promote that and then start to instrument the progress, that's when you really want to make it automated and repeatable. So deploying one command, Fabric makes it really easy. It's just fab production deploy, fab staging deploy. Fabric's written in Python. You can just describe your deployment process and as a Python script. So I want to copy these files here. I want to run this command. And once I've done that once, I can define multiple environments and say that staging represents staging.mydomain.net, and then production is web app 1 through 50 on mydomain.net, and then it's automated and repeatable.
Oh, and we have some that auto-deploy, like Jenkins pushes it for you.
Exactly.
I have a question.
Go for it.
So I have a system I deploy to staging, and I use Spring Loops to automatic deploying, and that's the basic, all I do. Is that what you're talking about when you're talking about deploy, or is it just it's way complicated than I'm even thinking about?
I don't know Spring Loops.
Spring Loops is kind of like a Basecamp, or that company has its own version of.
And they'll take your Git repo, log into a machine, and then, okay.
Yeah, deploy.
So it's basically, it sounds like that as a commercial service,
Yeah.
whereas Fabric is just an open source tool, allows you to do that in Python without the web UI.
Okay. So to be
I don't think the tool matters as so much as the process that's in place.
So I was saying, I have a process, do staging, manually check the code, do live. And
Yep.
That's all I do.
And I think that's a decent start, right? Do you run tests? Do you check on failures? Like, do you actually do any QA on that,
On the staging.
in the staging environment?
Yeah, but not as much as I should.
Right. And then can you roll back easily is the other piece of this, right? If I deploy to staging and I just blew it up, is it easy to undo all my changes? No. Yeah, so I think if you can solve those problems, the tool doesn't matter. I think it's really easy to argue over Fabric or Capistrano. They both do the same thing. One's Ruby, one's Python. One has a community with these tools, one has a community uses other tools. But as long as you're using one or the other or some similar tool, I think that's the real goal, right? So the two I'm a fan of are Fabric and Capistrano. I personally use Fabric. And then how many of you use continuous integration tools? It sounds like Jenkins is widely used. I think pretty much everyone uses either Jenkins or more importantly Travis. But a lot of this stuff can be done with Jenkins. So Jenkins just allows you to manage builds, does continuous integration. So what is a build? Build is a series of steps to do deployments and run tests and generate reports based on those tests. And it's pretty extensible. I highly recommend using continuous deployment and continuous integration. So the goal here is that every commit I can deploy and test, right? I want to be able to, doesn't matter who does it on our team, doesn't matter what environment you're in, if I make a commit, I should understand what are the result of the test suite and is it running on the latest staging environment. And then again, this is what Logstash looks like with Kibana. Actually, there's no Kibana on this, but essentially you can just pipe all of your log messages in here, and then you get a search UI. So what you can do is create canned reports, like show me all the HTTP access logs, or show me all the HTTP 500 errors that Apache has logged. But you can be more granular and start to log stuff from inside your application. So send all of your application logs here and look for everything that has this exception, right? So instead of trying to tail, which I think a lot of people have probably SSH'd into 3 machines and just tailed and look for the request that went into which machine and try to find the exception, you can go into one place and just look. So show me all the memcache logs and where the SSH is not involved. Splunk is another commercial service that does the same thing, has a nice UI as well. Sumo Logic is very similar. These two are paid tools. I believe they both have free plans to start with. So how many of you had to deal with Sphere outage? How many of you have had like your primary application go down and was completely unavailable, and you had angry executive team, angry customers, everybody's furious. And they want you to have answers. And you're like, I have no idea what happened. It's 2 a.m, I just woke up. Like, I've had this happen to me several times. And I have no idea where to start. I'm like, well, it's not resolving, so maybe it's DNS. Okay, well, here I have an IP. Can I get into the server? So when you do that, you'll quickly realize like logging is not enough. Like you actually have to understand where to look, especially when you have distributed applications. You have these 5 tiers talking to each other. Which one is causing the problem? Is it even your fault, or is it some third-party service? If the website's just outright not working, probably your fault. Probably within your control, right? If things are just really slow, who knows what the problem could be? So you really need to instrument and use monitoring tools. Again, Nagios allows you to check service availability. Is it up or down? Sensu allows you to do much more granular health checks based on your DevOps roles, so your chef roles. So I want to check for SNMP, check for some particular metric. Availability monitoring is not enough, right? It's not enough to just check whether something's up or down, or whether something's up but responds within this timeout. That's essentially Graphite. You can track any custom metric and then plot it over time. How many of you use performance management tools? How many of you have heard of New Relic or App Dynamics, or have used one or the other? Right.
Use it in the past.
Yeah. I don't want to go too much into a spiel about App Dynamics, but basically, tools like App Dynamics and New Relic allow you to understand your application topology, and then really what they do is they figure out how healthy is the application performing, and when things go wrong, you can actually drill down and see, oh, this line of code is talking to this third-party service. So when you're having outages, you can just go in and say, hey, here's where the problem is, right? So it doesn't really matter which tools you use, but you should have something like that. So how to win? Automate everything, whether it's your infrastructure, whether it's your deployment process, whether it's how you do logging, everything should be automated. And this is the most important piece, plan to fail. I think so many people, if Obamacare has taught us anything, is that you should plan to fail, okay? Everyone went into that saying, hey, we're gonna turn on this website, no big deal, boom, done. And it blew up in their face, right? Because they weren't prepared. They didn't test for capacity planning, so they failed to do capacity planning, they failed to test their infrastructure, they failed to see what happens when services go down. So if you ever talk to somebody like a Netflix, who's one of our largest customers, they do something called monkey wrench testing, where they just send somebody into the data center and start unplugging stuff and turning off services and shutting off ports and seeing what happens and seeing how they fail over. You should do this. This is gonna save you so much money and time later, right? If you do this just spend a day on it before you go live and say, oh, what happens if I turn off Memcache? Does it stall all the requests, or does it just go to the database and hammer the database really hard for a little while? Or does it blow up the application, right? If I lose access to this data center, do things fail over to our other data center, or do they just fail? So spending time to actually think about that and understand your points of failure is going to be huge. So, and then gaining maximum visibility with minimum effort. This is where all these tools come in, right? Whether it's monitoring tools to understanding, I want to be able to pipe all my logs into one place so I can be able to search them really easily, to I want to add application monitoring so I understand where things fail inside the application, to monitoring infrastructure. And then the last point is understanding your real value. I can't reiterate this enough. Nobody cares when things are working. So you have to go out of your way to show your team's success when things aren't failing. Everybody understands your value as soon as things start failing, because they know they have no one else to call except you, and they have to deal with whatever you tell them. If you tell them it's going to be a day, all they can do is go find somebody else besides you to try to do your job, right? So understanding how to sell your value is really about understanding the impact that you have on the business, right? So if you're running an e-commerce application, it's really easy to say, last year, or in the last release, we had 98% uptime, we had 100 severity 1 incidents. In this release, we had 80 severity 1 incidents, and we had a 99% uptime. Well, here's how much revenue that correlates to. So when you want to go and fight for your team's raises during the quarterly reviews or annual reviews, you can justify it by saying, oh, well, actually, we were proactive, we added all these different tools and this monitoring, and we actually increased our SLA and we increased our availability, and that correlates to X number of dollars. So my raise is not that big of a deal. So I found they did a bunch of studies, and they basically found the DevOps team spend more time improving things and less time fixing things because you're always prepared for the continuous cycle of change and deployment. DevOps teams recover from failures faster because they have access to the information they need. And DevOps teams release apps more than twice as fast as non-DevOps teams, which means if you're doing the manual process, you just spend so much more time doing that than clicking a button and saying go. So how much does an outage cost in your company? That's the question you need to answer for yourself, right? And you need to be able to tie that to your success. And that's all I have for you. Any questions? All right, well, thanks for joining. Enjoy the rest of Ski PHP.